this is part 2 of the movie about hyperbolas, where we're going to allow the center to be somewhere not the origin. And just as with the ellipses, you're going to see that when you have x minus h in the square, so that means we have moved the center h to the right. So if you see x minus 3 squared, we moved it 3 to the right. And then if you see y minus k squared, we've moved the center k up. So if you see y minus 5 squared, it's 5 units up where the center is. So let's look at some examples. Here's find an equation for the hyperbola that has a center at 1, 4. So I'm always going to draw the pictures so I can visualize. So that's my center at 1, 4. My focus is at -2, 4. So there's a focus point. A vertex at 0, 4. So I can see the setup here where the center is at 1, 4. The distance from the center to the vertex in the x direction is 1. And I can see that the transverse axis is going to go parallel to the x-axis, so I know the x term comes first. So I know x minus the x coordinate of the center is 1, quantity squared over something squared, but I don't know what yet, minus y minus 4, quantity squared over something squared, but I don't know what yet. Well, in the x direction, I can see that it's a distance of 1 from the center to the vertex, so I know this is going to be over 1 squared in the x direction. And then the distance to the focus, let's see, that's 1, 2, 3. So the distance from the center to the focus is little c, and that equals 3. So c squared equals 9. So that tells me that 1 plus this number that I don't know has to equal 9. So that tells me the number I don't know has to be 8. So the denominator under the y squared term is 8. So remember that means we're going to go plus or minus 2 root 2 in the y direction to help us draw the hyperbola. Now we know we have symmetry, so if it's 1 from the vertex to the center, it's 1 from the center to the other vertex. And if it's 1, 2, 3 from the focus to the center, it's 1, 2, 3 from the center to the other focus. So now we know in the y direction it's 2 root 2, so that's about 2.8 from the center. So go 1, 2.8. And 1, 2.8, so that gives us our rectangle. And remember, the vertices are points on the graph of the hyperbola. The rectangle gives us the asymptotes. That should go through the center. And then we know that the x term is first, so the transverse axis is horizontal, and the graph goes through the vertices and approaches the asymptote. So you need the y direction points just so you know the shape of that rectangle so you can get your asymptotes placed correctly. Okay, so let's look at number 48. Here I have vertices at 1, -3, and 1, 1. So this is a vertex and this is a vertex. So I know for sure that because these are 1, 2, 3, 4 apart, that the center is in the middle between them because of the symmetry of the hyperbola. So I can see that the transverse axis is parallel to the y-axis, so I know the y term is going to come first. So I'm going to write what I know so far. And I can see that in the y direction it's 1, 2 from the center to the vertex. So I know it's going to be 2 squared is what goes under the y squared term. So now I got to figure out something about the asymptotes. And let's see. The asymptotes here are in point slope form. So you have y minus negative 1 equals 3 halves the slope times x minus 1. So can you see that the center is the point 1, negative 1, and that's the point that the lines have to go through, the asymptote lines. And we know that the slope is 3 halves. So if we go 1, 2, 3 up and over 2, we have to get to another point that's on the line. And down 3 and backwards 2, we have to get to another point that's on the line. So here's the line that's the asymptote. But we know this vertex is a point on the hyperbola, so we have to be approaching this asymptote. Okay, so we also know that the vertex will be on the rectangular box that we're going to draw, that this asymptote is the diagonal of the box. So we know where the box goes because we can see where the diagonal of the box has to go. So you can see that from the center, if we go up 2 and over 1, that's not going to be quite far enough. Our slope needs to be 3 halves, and we know we're going up 2 and over, we don't know how much, right? We can't guess from the boxes on the graph. So we want to solve for this unknown thing, so let's call it P. So 3P equals 4, and P equals 4/3. So that tells us that the point, we go up 2 and over 4/3, so this distance is 4/3. So the amount we go in the x direction is 4/3 squared, which looks a little weird, but that's correct for getting the correct slope of the asymptote. And then we can see where the center is. So we're going to have y plus 1 quantity squared and x minus 1 quantity squared. And see how that matches up to what you're seeing on the equation of the asymptote. So the other asymptote would have the slope of the negative 3 halves, and then we can see what the hyperbola needs to look like. So we were supposed to come up with the equation of the hyperbola, and here we go. This is it. Make sure we got the right instructions. Yep, find the equation and graph the equation. Okay, so then here are a couple of other examples that are going to involve more completing the square and making sure you get the 1 on the right. So let's do the first one where you need to make sure you have a 1 on the right hand side before you try and figure out what's going on with your hyperbola. So you're going to have x plus 4 quantity squared over 9. The y minus 3 quantity squared is going to be over 1. If you want to write that, that can be helpful. So in the x direction, I'm going to go plus or minus 3. In the y direction, plus or minus 1. Are you seeing that the center is negative 4, 3? So I'm going to draw my picture where the center is negative 4, 3. Then in the x direction, I'm going to go 3 to the right and 3 to the left. In the y direction, up 1 and down 1. That helps me make my rectangular box. And the diagonals of the box will be the asymptotes. I see the x term is coming first, so I know the transverse axis is parallel to the x-axis, so I can see which points are the vertices and which are just the helper points for drawing the graph. So there's my equation. I found the center, negative 4, 3. The transverse axis, can you see that it's the line x equals 2, 3. Sorry, I can't see my dots very well. So it's the line x equals 3. Then my vertices, I can see from the picture. So my vertices are, let's see, 1, 2, 3, 4, and then 5, 6, 7. So negative 7, comma, 3. and then 0, 3. And that doesn't look right. This point goes right here. So if we go 3 from the x coordinates, then we're at -1, 0. And that looks right. So how I was checking it is I was seeing the distance between these 2 points is 6. And that needs to be this distance between the 2 vertices needs to be 6. Because under the x term I went plus and minus 3. So that's we found the transverse axis, the vertices. Let's see if we can find the asymptotes. So it's y plus 4 equals the slope of the asymptote looks like it's up 1 over 3, so 1/3 times x minus 3. This is in point slope form, and you're perfectly welcome to leave it in point slope form. If you really don't like it this way, then feel free to solve for y and put it in slope intercept form. But this is perfectly good form. Okay, then to find the foci, I need to find little c. And little c squared is going to be the sum of the denominators, so 10. So c is going to equal plus or minus root 10, which is between 3 and 4, closer to 3. So I go 3 and a little bit, so root 10 to find the focus point. But notice that you're starting at -4 in the x. So it's -4 plus or minus root 10, comma, and the 3 doesn't change. So one of the coordinates is always going to match up because of your transverse axis being x equals, y equals 3. Sorry, what was I thinking? Y equals 3. So see how y equals 3, y equals 3, y equals 3, y equals 3. So those should all match up. So let's do number 58 in class together, and we'll work on that tomorrow.